Hey there. Today, we're diving into the world of remote repositories in Google Cloud's Artifact Registry. Picture this. You have Python applications demanding diverse PyPI dependencies, and the deployment of these applications requires other public artifacts like Docker images from Docker Hub. You're looking to run these applications on Google Kubernetes Engine, Cloud Run, or possibly even Compute Engine, right? But here's a snag. Pulling from these public artifact repositories can be a bit of a security gamble. Here's where we stage a rescue with Google's Artifact Registry, and more specifically, remote repositories. They seamlessly weave a controlled interface between your software artifact usage and their sources. Ready to create your own? Let's jump over to the Google Cloud Console right now. First up, we head over to the Artifact Registry service and switch on the API. When we create a repository, let's, for simplicity, demonstrate Python and Docker. Just keep in mind that other options exist, like for Java, JavaScript, and Linux packages. Importantly, we're opting for the remote repository mode. Note that although virtual is a great way to bundle repositories for easier configurations and safer ordered dependency resolution, we won't be talking about this today. Docker with remote repositories means a link to Docker Hub. We need a region, so let's just pick one and hit Create, leaving the rest of the defaults. Next, we create a Python remote repository, which will use PyPI. Here's the good part. You can now set IAM permissions, granular networking controls, and service perimeters around these Python and Docker artifacts, an important layer of protection for your software supply chain. Remember, it's essential to place your security controls on your apps to avoid bypassing these curated remote repositories. For example, if applications can use Docker Hub or PyPI directly, your secured repositories will be of no use. A solution could be as simple as disabling public internet access for your services and systems. Now for the fun part. Let's test our setup by creating a Compute Engine instance and see our new assets pulled through. Keeping things simple but secure, we'll create an instance that makes use of the container optimized OS. If you'd like, you can tune the access scopes. Just make sure you have at least read only access to storage for the artifact repositories. Thankfully, this is included in the default access scope. Everything else looks good, so let's give birth to our shiny new VM. Our in-browser SSH feature comes in handy, so we can run some tests. For the containerized optimized OS, there's a Docker credentials GCR command, which is going to configure our Docker CLI here so that we can pull images from our artifact repository. Specifically, we set up our registry in the US Central 1, so we'll run a command like this. And now, if we try to pull the latest Nginx image from Docker Hub, we'll see it successfully pulled. Let's now go into Google Cloud Project, check our artifact registry, and see the cached version of that Nginx image here. Now, again, this gives us an entirely new layer of control. We can constrain services to use only certain images, for example, with binary authorization, and we can better control access to Docker Hub assets by using standard IAM controls. Now, let's quickly demonstrate the Python case. To test out that side of the equation, we're going to again simplify things with containers. Specifically, we'll use a Docker container that already has the gcloud CLI and a Python installation. We're going to pass our configuration directory to this container so that it can reuse some authorization. Now, looking at the setup for Python packages, note that we'll need to do some keyring library installations. So let's do that here in the Docker container. Just copy these commands verbatim. If we now try, for example, to install pandas for our custom index, we'll hit the repository and be prompted for a username and password. Let's opt for a gcloud CLI login instead. We'll set that authentication as the application default and take care of that process on a separate screen. After that login, we can retry the pandas installation and this time get a successful PyPI module pull. Let's check this out in Artifact Registry. As expected, we have our pandas package and its dependencies. We'll keep an eye on the comment section for any questions. Thank you for watching, and please enjoy responsibly.